Thank you everyone for being here. We're super happy to be partnering as I'm representing the WiMLDS Paris team, and we're happy to partner with Société Générale in order to make this event happen. So for those of you who do not know WiMLDS, it stands for Women in Machine Learning and Data Science. It's a global organization, and our goal is to promote and support women and gender minorities in the fields of machine learning and data science. So usually we do physical and free meetups during which you will hear women or non-binary speakers introducing their research work or their industry work. And because of the global situation, now we moved online. So that being said, tonight you'll see we will have 3 different moments. Claire is going to do a short introduction after I'm done speaking. Then you will hear Margarita Kokolova talking about cross-year multimodal image retrieval using Siamese networks. So she will be our WiMLDS speaker tonight. It will start around 5:40. Then we will have a roundtable about transforming data into value in finance. You'll see it will be different women from Société Générale, and the panel will be moderated by Zainaba El Khalil. And at the very end, we'll have Cyrielle Montoriol, who will be introducing to us how to detect omissions of risk factors in company annual reports with NLP techniques. That being said, I'm going to hand over to Claire in order for us to introduce tonight's session, and I wish you all an amazing moment.
Hello, hi everyone, and hi Caroline. Thanks for this a great opportunity to be together today. And I can see that some in the room are saying long time no meetups. Definitely a long time. But life is progressively getting back to the new normal. We're delighted to be together tonight. It's a big event because it's part of AI for Finance. Working across technology for 15 years, finance is probably one of the fields where there is the most opportunity for AI and next-gen operating models. Within Société Générale, that's one of the areas where we really try to push, the opportunities, the use case. I cannot be more delighted that 5 of our data scientists are going to share with you tonight their experience, what they do in day-to-day. I will stay and listen as well because I'm always curious and I always want to learn more. So I would like to thank you, Caroline, to receive tonight Marion, Lucille, Lauren, Nathalie, and Cyrielle, checking a bit the name on the side. And just to share a little bit maybe about my story, because maybe that's some of the for some of you on the call. But I graduated as an IT engineer, and actually in the field of cognitive science and artificial intelligence, and actually finished first of my class. And I was one of the only women in my class, as you can figure out, about 15 years ago. And I'm delighted that today there is much more. I go back often to school, and they committed to, they have now between 10 and 15% of women across all disciplines in IT engineering. But when I was going to the market 15 years ago and finding my first job, honestly, there was no job for data scientist. It was not a field where you will make a lot of money. It was a field for research. And I went into consulting, did my research at MIT around how large organizations digitize and transform. And then I decided to go, I was in the US, decided to go in London because I was specialized in financial services and fintech around the startup and how technology is changing the way the economy is financed, but also the way banking is working, and therefore how we access money on a day-to-day basis, be on our consumer segment, and how we interact with payment. And we can see the Chinese model like WeChat and Alipay, which are drastically different from banking as we know it in France today and in Europe. But also, more importantly, in the way access to financing is done, and in all the fields. And about 2 years ago, I decided to join Société Générale and come back in France, because France is my country, and I wanted to work a bit there because the ecosystem was growing very fast, and I've known the London ecosystem and the UK ecosystem growing like that, and I felt it was a good moment to make this move, because I like to see the emergence and to be there in the first phase. And I think France today is one of the best spots if you want to work in AI, because it's flourishing as much in terms of research, job, universities that have developed their curriculum around that, companies that want to work with more AI and data as part of our day-to-day job, and also investment, being VC. And you may know that, but the French government have taken action to prevent foreigners, investors to come and invest in technologies that could be sovereign technologies, and to protect AI about that. And I'm very happy that in France we are starting to invest more in women, and I've seen with delight, some of the laws that were already in place for board to ensure parity, but also now that are going to come in executive committee. I'm one of the lucky women in technologies that work at C-level. I work directly for our CEO, Frédéric Oudéa, because he saw the importance of technology, not as an end by itself, but as part of our transformation, and with all our business units. And I wish there is much more of them and much more of you. And what I can tell you is definitely AI is probably the right segment to be in today. It's probably going to be for the next 10 years, the areas that are going to deeply transform. There is a lot to do because China is obviously taking a lot of advance and testing this technology very, very advanced with their consumer base, because it helps them to leapfrog and to equip some of their citizens with facilities that didn't exist, and technologies they are facilitating this access, but they have really decided to push forward this agenda. And I think there is still time for Europe to really build a challenger and to keep the sovereignty, something we didn't manage to do for the cloud technology, but definitely could be the case for AI. So thanks everyone for your job and for your work. We'll enjoy again to hear our data scientists to present very concrete use case of what we are doing in SocGen. And just checking if there is a question. There is a question on data analyst, data scientist. I'm sure we'll be discussing that during the panel. So thanks, Caroline, and thanks for everything you are doing.
Good. Thank you, Kara, for your words. And now I'm going to pass on the floor to Margarita. I cannot wait to hear you talking about Siamese networks. It's a very, very interesting topic. Go.
Yes, Caroline, thank you very much for the introduction. And first of all, I'm really happy to be the speaker tonight, because actually I'm following these meetups for a year now, and yeah, and just cool to be part of it. I'm currently going to share the screen. Let's try to see it. That's going to be the presentation. And yes, let me, can please somebody just confirm me if you can see the screen fine? It looks a little bit weird here. Yep, okay, now I have a confirmation. Awesome. So, okay, hello to everyone once again. I will try to somehow check the questions on the application, but mainly I'm going to look at my screen. So if anything, I will also check them later on. And right now I'm passing to the presentation. So actually I'm a researcher and not a Okay, just one last checkup. I'm checking also if I have, if you can hear me fine. Okay. Yes, awesome. You can see and you can hear me. I'm starting finally. So as I told already, my name is Margarita, and I'm actually a researcher, not a data scientist yet at the moment. And I'm working in l'IRIS Lyon, École Centrale de Lyon, and IGN in Paris. And I'm working as a postdoc researcher. And tonight I'm going to actually introduce a work which is not about the finance, but about, well, it's more like a geography or image-based application, but I hope it will be still an interesting use case. And this research paper actually is going to be published very soon in ICIP 2020 conference. And you can also find the paper online. Okay, so cross-year multimodal image retrieval using Siamese networks. First of all, I'm going to talk a bit about research problematic. So actually in France, there is one very interesting project financed by CNRS, and the project name is Allegoria. And this project aims at facilitating the promotion of ethnographic institutional funds and collections of the French territory. That is to say that we actually have like lots of archives and images and old images of the French territory, which are now in archives, which were digitized for this project finally, and now we have them as images. And all these images, and well, not all of them are geolocalized. So ideally, we want to somehow create the tools for researchers to be able to search for these images, to basically work with them, and to ideally geolocalize them. And this project, like we use many tools in this project, but this is the research goal. So we have, as I mentioned before, different digitized archive data. So aerial and mostly aerial and ground view images, only of like French territories, and they're taken from starting from the First World War, right after it, and like coming to our days. And we also have actually multimodal cross-temporal data covering all France. In terms of actually IGN, since they produce maps, they have really precise, like manually labeled maps, and also aerial images representing all French territory. And this data are actually available as open source, so if you want to play with them, you can find them and also try something. So for this research project, we first actually decided to formulate the following task in order to try to find out and answer the following questions. Actually, can we retrieve the same geozones across time? That is to say, if we are having an image, for example, taken in 2004, if we can describe it or use a compact representation of this image and to retrieve it from the database in 2018. We have different modalities of data. So we have the aerial images, and we have a semantic annotation, which are hand-labeled. And to start with this research question, we actually started with perfectly aligned ground truth data. That to say, we took just the most old images of the French department from 2004 and the most recent one from 2019 from the database from IGN. And we decided already to try to match these images and see how it works. So it actually sounds maybe a bit too easy, but in the same moment, during the time, like we have lots of changes in landscape, we have lots of changes happening, and that's why we actually, well, even on this image, you can actually see that some buildings in green disappeared and some new ones were built. So there were significant changes, and we want to see basically if neural networks or deep learning-based descriptors can actually still be able to retrieve the images of the same date. If we can use the semantic data to use to improve the research results, which modality is more important for such a search? So to start with that, we actually created a small data set. I will go here quite quickly. So we basically just took some French regions. We cut them into rectangle zones. We selected some images, cut them further to create just patches of 2000 by 2000 square kilometers to represent the territory. And this is our data set, and it contains approximately 12,000 images. So it's not very big. And we have, as I mentioned before, we have the aerial images, and we have the ground truth data. Let me just check once again if you're still following me here. Yes, sounds okay. Good. So this is our data. And what we want just to be able to retrieve a corresponding image. If, for example, one image is given, and in the database, there is a corresponding image, we want this image to be retrieved correctly. We also use some semantic categories, and here we selected just some most important man-made semantic categories and some natural objects like rivers and vegetation zones like forests. And these were manually labeled by people before, but we just had this data, so we decided also to use them. And at the first step of this work, we actually tried just a very simple baseline in order just to already to see if a standard CNN network pre-trained will be able to solve this task of automatic geolocalization. So the baseline is the following. We actually have just an image, an aerial image, and a semantic map as an input for CNN. I will introduce the CNN like backbones later on. We use pooling as a standard method after the last convolutional layer. And then we get just a descriptor which is a complex representation of our image. And we use a KNN search in order to retrieve the data in the database. So the input, for example, would be an image from 2019, and the database will be 2004. Hence, we're doing kind of research and retrieval task on our data. We use two baselines. One is actually super classical, which is just ResNet 50. All standard there, just pre-trained on ImageNet. And the other one was actually GEM, which is if anybody worked with image retrieval, this is kind of still state-of-the-art, which always takes pretty high ranks on all the competitions of like on image retrievals and landmark retrieval tasks. And we also took it like pre-trained on a data without fine-tuning on our data. We experimented a bit with different data fusion because we have both image and semantic data. So we tried to, for example, well, you can just use network and then to sum up concatenated descriptors. It's possible to make a late fusion when you just calculate the descriptors separately for each modality and then compare the similarity results. And we also tried to do fusion by convolution of the two images prior to the input of the network. I'm going to talk a little bit later more details about it. And here I'm just going to tell you about these baseline results because these are not so interesting, but we just discovered that, well, right away, these networks pre-trained on other data, even pre-trained on like landmarks data sets, are not very good for us. Because the accuracy, even for this task, is pretty low. The best results we actually got by using the data of both modalities and the late fusion. We got some better results, surprisingly, or maybe it's not that surprising, but we got better results with ResNet in comparison with the GEM. And overall, yeah, so overall, for our data, it was best to use both modalities, late fusion, and adjust your ResNet 50 network. So this was the first task, but with this baseline, we see that the results are not very good. I mean, the best accuracy is around 0.8%, which is not very high for the real application, taking into account we have somewhat artificial task when images are really, we have the same zone, it's just separated in time. So there was a way to, what we wanted actually to try to still fine-tune and see how can we improve these results. And for that task, CMS networks are actually one of the most famous solutions. And I'm going to demonstrate you how can you use CMS networks for such a problem, or maybe later in your research. So CMS networks are usually used in single shot learning. So basically the case when you have really few samples or training samples per class. And this is the case here because we have a single image correspondence. So there's a single zone corresponding in 2004 to the zone in 2019. And so we decided to use the CMS network, hence, to fine-tune our descriptors, to try to improve these results and to see how far we can go and how good can it work. Here is the architecture. The architecture is completely custom, but if somebody works with CMS networks, it's not that novel, but there are some changes. So we still use both as an input of the network. We still use both aerial image and the semantic map, which are fused together with a convolutional layer. Then there is a standard ResNet 50 as a backbone because we discovered it was working fine before. Okay, no, I don't have time to stop for that. Okay, and then there is a basically we have some more convolutional layers and a fully connected layer to form a descriptor. Then to train this network, it's commonly we try to compare the positive and negative pairs, and we try to make the distance between the most far away. And in this scenario, we actually discovered that it worked much better to just try to predict whether the input pair corresponds to the same zone or to different zone. Hence, the input for our network is actually a positive pair and a negative pair. And then we have let me go to the next slide. And then we have actually a very simple binary cross-entropy loss, which turned out to work way better than some fancy losses on this data. And this, this is quite complex math. It looks like it, but in reality, it's just a binary cross-entropy loss, which predicts whether the pairs of the network are same or not. And we decided to use also to make it completely fair. We use different departments for training and validation, and we use also different departments as a test. I will super quickly still check if I have a message here. Okay, no questions yet, so I will come back to it later. And of course, very important, if you're ever going to work with CMS networks, so far, mostly it's very important to actually use hard mining. So you need to select hard samples or misclassified samples and give them and add them to the batch, because otherwise it doesn't work very good. So we actually tried different hyperparameters, which is not very interesting, but briefly just to tell what we finally used. So we used the descriptor size of 128. We trained all the network for quite a long time in order to get the optimal performance. It's also pretty common that CMS networks are trained for very long. We use the batch size 12, but that's mostly because we didn't fit anymore. And in KNN, we tried different metrics. And we also actually compared our method with the SimCLR method proposed recently in this year, I think by Google, and the different loss, which worked worse for this scenario, even if it's also like contrastive learning. So it's also one of the note to have that sometimes you need to really experiment to see which networks and parameters work best for a given task. So with that, I'm actually just coming to the results. Yes, so even if you use this CMS architecture proposed before, in the end, when you're testing the results, we just use one branch of the CMS network. And when it's trained, it just gives a descriptor. And overall, like I have here the best baseline, and we improved the results approximately for 20%, fine-tuning only on the training data, and we improved both on validation and testing data. We also we've done all kind of cross-validations in order to check that the method is really generalizable and the CMS network can be used in this context, which all worked pretty fine. Okay, I do have 4 minutes. So, as I mentioned, we compared it with another loss function and another method which works also with a similar context with the CMS network and contrastive learning, but it worked less good. And we have better results in all the cases. I put actually some tiny, well, we tried also different parameters of this network. All this, I guess, you could just find in the paper. But in any case, like with the descriptor size, we tried different descriptor sizes, and there are some images. Basically, if this will be the query of a 2019, this is the results returned, and this is an example of like a mistake because we still have some errors, although not very big, and mostly we discovered that all our errors are mostly coming from areas with the forest when there is really nothing and the annotations are pretty different with the like query and the correct match result. And yeah, there were some more ablation studies and parameters for this work. Yes, this I guess will be also better to just take a look at the paper in order to find out more details about that. But we tried different parameters, different architectures and different activations, and also compared different loss functions. And with that, actually, yes, I think I have just several minutes left. So I'm going to conclude on it. So here we're just proposing a kind of a novel approach for learning from multimodal data using Fusion, and we like propose a new architecture to fine-tune basically any CNN-based image descriptor and any with any backbone. So this code can be used for any other application. Well, we just produce a small, a very compact descriptor, which is powerful enough and can actually distinguish between, like it can still help to retrieve the images across time, which didn't work without this fine tuning. And we also propose actually just kind of a new multimodal data set, which is very interesting because it's kind of a novel task. So also it might be interesting for somebody who is working with geob data and remote sensing data. Yes, so with that, I actually just wanted to thank you for your attention before passing to the questions. And actually, yeah, the paper is available. There is a French version already available, and there is an English one which will be published shortly. And there is a code available on the GitHub. And I just advise you to contact me if you have any questions. We won't have enough time to answer to them right now. Okay, this I can skip. So for the moment, I am getting back here and looking at the chat to see if there are any questions and if I can actually answer them. Okay. Yeah, so well, there is first one question about can we use machine learning and remote sensing together? I'm not quite sure what exactly do you mean, because here we do have just remote sensing data. And I think actually remote sensing and all kind of geographical data have lots of potential for machine learning. Well, because we just have lots of data. And as you all know, machine learning and especially deep learning is just so data hungry. So with this like really huge amount of data, we have a potential for all kind of applications and all kind of things. Please just precise the question if it's not the correct one. So the labels used in the modeling. Okay, let me get back quickly to the slides. So the labels used in the modeling were pretty simple. So the labels themselves are like semantic maps, if this is what you mean. So we have a remote sensing image and a semantic map, which is actually just a manually annotated data about what is placed, what is located in this zone. So this will be like houses, forests, roads. Well, basically it's like Google Maps or OpenStreetMaps. So well-known data. Since they were already manually annotated by the researchers or by we do have these maps available, so we can use them. The only problem is that they're annotated always differently, and we change from year to year, and there are lots of things which make this task less easy than it seems. And the label here, if you're talking about training, in our case, it works the best. And we're just using cross-entropy loss, and then the label is if it's a positive pair, when there are images representing the same zone coming from different years, or a negative pair is when there are images representing different zones, and that will be a negative pair with label 0 and positive pair is label 1. And then we just predict using a normal like sigmoid layer. We will just predict the probability if it's a same zone or different zone, and that will be our training. Coming back to the questions. Sorry, I'm just using my, okay. Yep, so this was a, yeah, so there is a question about what tools did we use to handle satellite images, the size and the cloud tools. No, in reality, this is the research work. So I probably also missed it during the presentation. The input size of the images we used was maximum 1000, and in the final network is even 500 by 500. We had the liberty to actually select the input size of the images. So we cropped the images, and we decided to cut them to make the fixed size. Otherwise, but it still was lots of data, and hence we need lots of GPUs actually to train it, and it makes some constraint. I think the results would have been better otherwise. But yes, for personally myself, I don't use any cloud tools. I just run it on a cluster on GPU, and the images size we select ourselves, but we use a standard size like 512 by 512, and then even smaller, 256 by 256 for the final tests. Yes, you're welcome. Okay. If I don't see any more questions, so actually, and my time will be pretty soon up, I'm really grateful for this opportunity. Once again, please just don't hesitate to contact me or just read the paper. There's even version in French. And with that, I'm actually going to finish my talk. And next, there's going to be a roundtable led by Zainaba El-Khald. And I'm passing the word to her, I guess. Yeah, there are still some questions, but please just contact me later on. That will be awesome. Or I will try to answer by text.
Thank you, Margarita. Just a quick check. Do you hear me?
Yes.
Okay. Perfect. Thank you, Margarita, for your presentation. Hi, everyone.
Thank you for having me.
Hi.
Sorry. Hi. I would like to welcome you to our discussion panel, where we'll discuss data science and finance. My name is Zainaba, and I'm working in the Central Data and AI Innovation team of Société Générale. Today, we will be focusing on two topics. The first one will be tackling the process of value creation from data science, from data in Société Générale activities. In order for you to have a clear picture, as Claire mentioned it, we will give some examples and focus on some use cases. The second topic will be centered on the human faces behind this process. You can see them on the screen, primarily women. We will get to know more about women working on data science within our group and share with you their backgrounds, visions, ambitions, and their daily work. Today, I'm very lucky to have a great panel of data scientists, 4 data scientists from 3 data labs within our company. It is interesting to know that at a global level for Société Générale, we have more than 20 data labs, and our data science community counts more than 150 data scientists. Please feel free to ask questions in the Q&A tab. We'll try to answer them all if we have time. At the end of the panel discussion, if we lack some time, we'll come back to you later. Ladies, to start with, please take over the floor to introduce yourselves to our audience. To get to know you more, briefly, maybe state what you want to know, what you want us to know about you. Let's maybe start with Lucille and Lorraine. You're working closely, and then we'll pass on to Marion and Nathalie.
Yes, thank you. Hello, my name is Lucille. I'm 25 years old. I have a master's degree in applied mathematics with a major in data science. I did my internship at Société Générale, then I was hired 2 years now.
Hello, everybody. My name is Lorraine Yempi. I have an engineering background in embedded systems and signal processing. I have also a master's degree in machine learning and big data from Telecom Paris Tech. I have been working at Société Générale for 2 years and a half now, yes. And before that, I was a product manager for 7 years in the automotive sector.
Hi, my name is Marion Cabral. I graduated in 2012 from NSAE and the Laure Elie Master's Program, which is a master's in statistics and probability with a specialization in quantitative finance. I did various internships in structuring and trading, and I was then hired in 2013 by Société Générale as a quantitative engineer for the division in charge of large corporates and financial institutions. And 2 years ago, I started working in my current position as a data scientist within the digital office for the corporate and investment bank.
Hi everyone, I'm Nathalie and I'm 25. I graduated from Telecom Paris Tech with a major in data science. I've been working as a data scientist at Société Générale for almost 2 years. And prior to that, I did a 6-month internship at Société Générale.
Thank you for these introductions. Now, in order to help us understand your role within Société Générale, as being an international financial institution with a wide range of financial activities, serving more than 30 million individuals, businesses, small and big businesses and investors, I would like you maybe to give some information to our audience about the business activity or the function you and your data lab team work for. Lucille and Lorraine, maybe you can start.
Yes, thank you. Lorraine and I work for the data lab for general inspection and audit, which are the bank's third line of defense, or what we name LOD3. It's the periodic control. In a bank, we have 3 lines of defense. The first line of defense, what we call LOD1, made up of the operational business team that control its own processes. The second line of defense, LOD2, composed of permanent control of the activity supervised by an entity detached from the business team. Our main duties in the LOD3 consist in working on all the bank subjects, investment banking or IT-related topics for Lorraine, and retail banking related topics in my case. The data lab is composed of 20 people in France and about 15 people abroad in Eastern Europe, Africa, Asia, and in the United States.
So for my part, I work in a team of approximately 20 people located in Paris, London, and New York. So the team covers all the wholesale banking division, meaning global markets, securities, financing, and global payment services. So we work for a wide range of internal clients.
As for me, I'm currently working in the modelization team of the risk department of Société Générale that deals with financial risk and in particular credit risk, but also offers data science solutions. So our data science team gathers about 15 people who are in charge of developing and implementing models for every risk department.
Thank you. So now that we got to know your role within the group, we will know you more. Let's talk about the use cases you're working on. for our audience, one or two projects you delivered recently or that you are currently working on? Let's start with you, Lucille.
Yes, of course. I will say that the fight against fraud, whichever from anti-money laundering to terrorist financing, including internal fraud, is definitely one of the major topics investigated by the Inspection and Audit Department. Retail's client financial security is a recurring theme in our missions. Indeed, as previously discussed, we are the last line of defense, and part of our activities is to make sure, as much as possible, that neither fraud, nor money laundering, nor terrorist financing networks remain undetected. In order to address this problem, we have created a transactional graph or network that we have decomposed into communities. Then, for each of them, we created variables to describe each of those communities obtained. We then applied supervised learning and algorithm to classify the communities between LC, the non-fraudulent ones, and suspicious ones. This project final goal really consists in designing a tool that can evolve and adapt to the ever-changing fraud patterns without requiring any human-based explicit description in transaction monitoring systems. Currently, several projects are in progress to improve global knowledge of these complex operational subjects. The first one is creating communities coherent from a financial crime analyst operational point of view using social network analysis methods. The second one is the feature creation thanks to the automatic graph embeddings. And the last one is the improvement of the classification model's performance using neural network. The main difficulty on this project is the fact that fraudulent networks are fortunately very rare events. It's really like looking for a needle in a haystack.
Very good introduction, Lucille, for our work. In fact, as you mentioned, anti-money laundering is a problematic for which many challenges remain open, especially covering investment banking perimeter. Additionally, it appears really complex to model. So far, our scope of activity focuses on corporate clients because we need to start somewhere, and also because it is a priority for the business. We have already started to work, we have already worked, in fact, on the detection of atypical transactions using unsupervised models. And we are currently keeping this work up by focusing on clients' field. So we want to develop another approach, which is based, in fact, on neural networks and graphs, and is divided into axes. So we are at the early stage of this new approach. So the first axis consists in detecting atypical clients on static graphs, and the second axis is more dynamic, and we want to exploit the time dimension to detect atypical subgraph profiles. So for both axes, feature engineering is really important, both at the nodes and at the edge levels. And as you said before, Lucille, fraud is really difficult to find, and we need absolutely to collaborate with experts. Now I hand the floor to Marion.
Well, so I'm currently working on a no-casting GDP project. So no-casting is a contraction of the two terms no and forecasting. So the objective of the project is to predict GDP at different times in the quarter. So a GDP growth is predictions are very useful for policymakers to assess macroeconomic conditions in real time. So they can take crucial economic decisions based on that. So consequently, it's very useful for departments working on markets too. Like trading desk or investors. So these predictions are directly used by our macroeconomic research department, but also indirectly used by other departments, such as departments working on markets, but also our management. So they will use these predictions of GDP as an input in their models to predict different things, such as markets, but also the budget based on different economic scenarios. So to better understand our constraints and the context, it's important to know that the first estimate of GDP is obtained 1 month after the corresponding quarter. The real value of GDP is based on national accounts, but we can obtain an approximate value by taking into account many variables, such as different surveys, figures, or alternative data. So, for example, we use surveys on industrial production or unemployment rate figures. But the problem is that these figures are obtained at different times in the quarter, and we would like our GDP predictions without waiting to collect all of them. So basically, our objective is to track the real-time data flow using a single coherent framework. And so the data flow, as we just said, but also the low historical depths of data. So why low historical depths of data? Because so the GDP, its frequency, it's quarterly. So even if we take into account, let's say, 10 years of historical data, we're going to have 40 observations, which is far from what the standard machine learning models require. So some econometric models, such as a dynamic factor model, or other standard machine learning models address these issues. But for this project, we would like to build a more sophisticated machine learning model.
Thank you, Marion. So as I remember, you also use some macroeconomic GDP data in your projects, Natalie?
Yes, in fact, I recently worked on developing a model to predict the residual values of used cars for Société Générale leasing subsidiary called ALD Automotive. So for those who are unfamiliar with the concept of leasing, it is essentially a contract between the company and a customer to rent a car for a determined contract duration and mileage. At the end of the contract, the customer has the option to buy the car at a fixed price. Otherwise, the used car is sold by ALD. ALD was asked by the European Central Bank to develop more complex stress test methodologies. To address this, we built a model able to estimate the used car sale amount for each car using the historical used car sales, macroeconomic, and market data. The model is then applied on the current fleet using stressed macroeconomic and market prediction given by Société Générale economists. Macroeconomic data include variables such as the GDP, the unemployment rate, while market data include the number of new registrations and its share of diesel vehicles. The model is now in production in the Madrid team of ALD to conduct stress test exercises.
Thank you for enlightening us with your projects. This is really exciting. I think the audience would definitely share my point of view. And it showcases the variety of topics that are handled within a bank data lab. Let's now take a step back and maybe get your vision on the issues faced by the financial sector nowadays, and how do you think that data science and machine learning can help address them? Let's start with you, Lorraine, if you don't mind.
Yes, of course. Thank you, Zainaba. So, from our point of view, the banking sector is an ecosystem of many challenges. We all know that, I guess. Banks have to face up to ultra competition. I'm thinking in particular of neobanks or online banking. They have to retain customers in the retail banking. They have to work harder to win more market shares in investment banking. They must constantly ensure compliance with regulatory directives and protect themselves about cybercrime. So you see, there is a lot to do. So for me, the contribution of data science lies in the ability to improve our customer experience. For instance, by offering to the customer more intelligent platforms and services by why not offering them open banking, for instance. It also lies in the ability to improve our operational efficiency. It's especially in regulatory issues. Typically, in our department, it is data science helps to have a better detection of problems and to help to it helps also to provide accurate recommendations. So that is my opinion.
So yeah, well, as Lauren said, finance and especially banks have to adapt to an increasingly restrictive regulatory environment. And at the same time, they still retain a key role in the economy as they play a pivotal role providing credit, which is crucial, especially in times of crisis. And yes, like other industries, banks are increasingly opting for more sustainable and responsible role in finance. So yes, I mean, for example, with regards to everything related to ESG finance, so ESG, E for environment, S for social, and G for governance. So this refers to the three central factors in measuring the sustainability and social impact of an investment in a business. And yes, like other industries, the financial sector is dedicated in making innovation a cornerstone of its strategy. So how can machine learning help? It can help in accurately evaluating risks, providing tangible data and risk assessment to regulatory agencies. It can also help to detect which companies or people are facing difficulties and evaluate the risks behind that. It can also help to accurately quantify environmental and social criteria in companies, provided the data is properly collected. And yes, regarding innovation, many companies in finance or elsewhere put machine learning at the heart of their strategies to transform their business, to automate tasks, to provide more personalized services. So this is also the case in finance, but in this field, we also have a huge amount and variety of data, which enable us to address these challenges and increase innovation opportunities.
Adding up to Marion's words, indeed, the periodic control has carried out a mission on the theme of corporate social responsibility. The inspection and audit data lab was able to create a tool to monitor the reputation of a company from a corporate social responsibility point of view.
I completely agree with what you all said. I believe that in a fast changing world, finance and banks have to meet customers' needs. They are looking for speed, efficiency, reliability, and security. So as a large amount of data is collected by banks, machine learning contributes in having better financial forecasting, personalized customer services, and data security.
Thank you for sharing your visions. We surely learned a lot from you. I hope so. I would like now to go on a more personal ground and ask you a very open question, or maybe a set of questions. Please feel free to choose the part you want to answer. My first question is, what makes you passionate about data science, if it's the case? The second one, what are your ambitions for the coming years? And if you have a piece of advice to give to our audience, what would it be? I think especially of female students who wish to become data scientists like you. I could see some questions come in and comments from some students. I hand the floor to you, Lucille.
Yes, thank you. What makes me passionate about data science field? Data science is a science in constant evolution, both from a technical and an application point of view. In 5 years, I hope I'll be able to discover and learn about these 2 points.
Maybe I can choose why the question about why I decided to become a data scientist, and maybe also share a piece of advice. So before becoming a data scientist, I was an IoT manager in the automotive sector for 7 years. So at that moment, at the end of that experience, my dream was to be hired in a bank and to experiment its technical challenges. So the technical range in the data science is very wide, and the business aspect is as important. It's just as important. So when I decided to become to change direction, I didn't think about whether I could do it. So the only question that came to mind was just in which bank I will apply my new skills. So if you are passionate as am I, uh, there is only one thing to do. It's just to believe in yourself today because it worked for me. So you see, it's quite simple, just there.
I will pick up the question on my ambition, but I think I'm going to be a bit vague about my answer. Yes, some people are good at projecting themselves in the next 5 years. I have to admit it's not always the case with me, but I know I wish to develop more technical skills and contribute to responsible and innovative projects for the next few years. And about my advice would be to work on your machine learning skills and believe in yourself also.
I agree with what you said, Marion, and would add that data science can be applied in many fields, such as finance, sport, marketing, and so on. Your technical skills need constant improvement, and you need to keep track of all the new breakthroughs. So it's really a really stimulating environment to work in. And my advice would be to stay curious and to never stop learning new things.
Thank you all for sharing your passion and valuable advice. Again, I think our audience would appreciate it. I would now like to conclude this roundtable with the last question on how do you see the role of women in machine learning and data science? Claire mentioned it at the beginning of this meetup. Let's face the reality, data science still struggles with a massive diversity problem. Women only make up as few as 15% of data science professionals globally. This is a huge gap. So how do you think we can tackle this big issue? I pass the floor to you, Lucy.
Yes, I currently give Python lessons at Dauphine University, where I try to transmit my passion for data science to students. And I'm happy to see that there are more and more girls in Python classes, which proves that the subject is progressing.
So Lucy does very interesting things. From my point of view, as a woman and as a data scientist, I think that we should keep going to encourage ladies in school by organizing information sessions, share some examples, some success examples. In our company, in Société Générale, we should, or in companies in general, we should encourage management to create gender diversity in data labs. Um, our data lab is a great example of gender diversity. We have in Paris um, men data scientists and women data scientists in the same proportion. So I'm really grateful for that. So why not organizing technical workshops, information sessions, meetups, and so on, and demonstrate that any lady at the end can be a data scientist. I think if we encourage women such way, in the next few years, I'm ambitious, the population of women data scientists can be multiplied by at least by 2.
Yeah, I think we should promote this job to women at an early age. Women shouldn't already be in higher education before they hear about these roles. Little girls and teenagers should be aware that these cool and exciting jobs are made for them as well. And of course, with equal skills and competencies, fostering diversity in data science teams is always a good idea.
As Marion said, young female students are poorly informed about data science and its opportunities. This lack of information, coupled with few female role models, participate in keeping women out of data science. So we are doing this today to raise awareness and show women that they can be part of the AI data science industry in the hope to see more and more of them in the near future.
Thank you, Natalie, and thanks to all of you for this open and
Thank you.
passionate conversation
Thank you.
on data science. It was really great to hear from you. I learned a lot while preparing this roundtable, and I hope that our audience too learned things today. let's now take some questions. I can already see that we received some on the Q&A tab. Let's have a look and see if we can provide some answers. For those who are data analysts today, how to evolve to a job of data scientist? What must be done? Do you have any advice, girls?
Oh, well, work on your machine learning skills and believe in yourself again.
Okay, data is the fuel of AI. In your projects, how do you ensure to have the right and proper data? What is the role of users, customers in it? Anyone to pick this one?
Well, compliance is here for that. And yes, I mean, we have an authorization for that every time, so it's okay.
Okay. Question for Natalie. Has SG developed a risk model to monitor and forecast portfolio climate risk? If not, what are the major challenges in this field for the bank?
Yeah, so in our team, we are currently working in integrating climate risk, so transition risk and physical risk. So Société Générale is working on monitoring climate risk.
Question from Marie. This question is in fraud. In terms of fraud, do you use supervised learning? If so, how do you get the labels? Do you have enough examples to have a balanced data set?
Lorraine?
Start here. Maybe I can start. In our site, we didn't have we didn't perform supervised learning even for the first approach. It was completely unsupervised, so we didn't have labels. Now the results we have are in the side of the business to analyze them and to tell us if we should continue such way or if you have to change directions. It is really difficult to have labels in fraud because you know that in fraud things evolve very fast, very quickly. So the guy who frauds today will not fraud the same way tomorrow. So in my side, we didn't perform supervised learning.
Something to add, Lucy? Yeah, go on.
Okay.
Go ahead.
In my side on retail clients, yes, we have made supervised learning. We have labels thanks to transaction monitoring systems, a lot of alerts, and then analysts work on that. And then we know if that clients made a fraud or not. And yes, of course, we have a very, very unbalanced data set. It's a real challenge to work on that. We try some methods like SMOT, but we still work on that.
We'll take a final question from Harry. What new skills of data science are you learning recently, and what skill did you improve since those 2 years working in the company? Maybe if you can take one part of the question, Marion or Nathalie.
Well, I've learned a lot about nowcasting, of course, during the last months. So it was more about macroeconomics models, but it's still very useful for us. We would like to be closer to this world about economy and just doing a bridge between machine learning and econometry. So it's cool. It's cool to learn about that. Yeah.
The second part is in maybe Nathalie, if you want to answer.
So in what skill did you improve since those 2 years working in the company? Maybe I can share a skill that improved, but it's not data science related. So working in Société Générale as a data scientist, you also have to present your work. So public speaking is also a skill that you improve working as a data scientist at Société Générale.
Perfect, and this concludes really our roundtable. And I think with something like what we have done today, we surely work on our public speaking skills. Now I'm gonna pass the floor to Cyrielle to present her work, her research. Cyrielle is a PhD student working on Société Générale, and I will let her introduce herself and her work.
Hi everyone, let me share my slides. Okay. Can you see my slides? Great. So my name is Cyrielle Montariol. I'm a PhD student working at Société Générale, and I will present you my work about detecting missing information in financial reports. This is joint work with another PhD student from my lab called Corentin Masson. And first, some details about me. I got a master's degree in statistics, graduated in 2017, and I shortly after started my PhD, which is a CIFRE contract. So it means it's a partnership between a society, Société Générale, which funds my PhD, and a research lab, which is called LIMSI, and which is attached to the CNRS, which provide all the technical backgrounds. So we're working on data, textual data called companies' annual reports. To define what it is, first, I can say that all traded companies in France have to publish every year an annual report. So it's around 190 annual reports released each year. And it's the AMF, Autorité des marchés financiers, which enforces each traded company to release it. And the report contains an average of 3,500 sentences. So these are actually big books to explain everything that happens in the company, all the risks, everything that they created during this past year. So a lot of applications involve analyzing this kind of data. So this leads to some kind of problem linked to the analysis of this data, because there's more and more companies that release their annual reports, so a huge increase in volume. So we need more and more NLP to analyze this. But as the volume increase, the diversity of the patterns, of the size, the shape of those reports increases too. So more diversity means it's much harder to analyze it in an automatic way. So you need much more advanced methods of NLP to find a common pattern and to analyze jointly all the annual reports to make an actual deduction and information retrieval. So the application can be made from the side of the regulators, so the AMF, to check that all companies actually do what they ask them to do, so perform all the analysis and publish all the necessary information, but also from the point of view of a bank, for credit risk or market risk, all these kind of activities that could require analyzing everything that a company could publish. So we study companies' annual reports for 20 years, since 1998, and of three different sizes: CAC 40, CAC 60, and CAC 90. And from a long list of business lines, you can see some on the right, from information technology to energy, financial companies, healthcare. More particularly, one specific element that has to be reported in these annual reports is risk factors. So it's every risk that the company faced or has to face or might face during the business year. So you have here an example of an annual report with a list of risk factors reported. So financial risk, operational risk, strategic risk. However, sometimes some risk might be missing. And if a risk is missing, it could be important for an investor because it could change the way he could make an investment on the company. So the company could be accused to voluntarily omitting information which might be important for the market, and this is some kind of fraud that the regulator authorities try to fight. So our goal today is to try to detect this kind of missing information. So we constructed a pipeline of 3 steps. First, we take from all the annual reports only the sentences that deal with a risk. Then we map all the risk that we detected depending on the sector of the company, the period when the report was published, or the company size. And finally, we use these 2 steps to detect the omitted risk factors. So first step, extraction of risk-related sentences. For this, we will use a method called extractive summarization. So the main idea is to extract the most representative element of a text for a specific goal. As you can see on the example on the right, you go through a document and sentence by sentence, you classify them as representative or not. So it's binary classification. So in our case, for our problem, we want to classify each sentence as a risk sentence or not risk sentence. And for this, we will use 3 modules for extractive summarization. So this is our architecture. I will show the 3 different steps from lower one to upper one. So first, on the lower part, we have something called a sentence encoder. So we take each sentence one by one, and we embed it into a presentation space using a pre-trained language model called BERT. Maybe you heard about it. It's quite famous because it improved the state of the art in many NLP applications recently. And more precisely, we use the French version of BERT, which is called FlowBERT. So we embed each sentence as a vector of numbers, and we then use this for the document encoder. We use this because we assume that a risk evocation, so a moment where the company talk about a risk, this could be split in several sentences. So if you look at only one sentence, you might not realize it's talking about a risk. So we want to extract the embeddings of the surrounding sentence of each target sentence to know if this target sentence is actually talking about a risk or not. So for this, we use an LSTM layer on top of the sentence encoder. So this makes the document encoder. And this leads us to the final step of the architecture, which is the sentence classification. So simply, we take the context embedding, so the surrounding sentence embeddings and the center sentence embedding, and we use it to do the classification and decide if each target sentence is actually talking about a risk or not. But to do this, we need labels because this is supervised classification. So how do we do this? We don't want to randomly annotate a huge number of sentences. So we use something called active learning, and more precisely, pool-based query by committee active learning. The main idea to select the most informative subdocuments to label to increase the accuracy of the model without randomly selecting a large number of subdocuments to label. So the process is simple. First, we label randomly a small set of subdocuments to start, and then we do several active learning iterations until we reach a satisfying accuracy. So this is the process. We take the raw unlabeled data, we pass it through our active learner, which is pool-based query by committee active learning. This system selects which data to annotate. It passes it to the person who's going to make the annotation, usually a financial expert, which labels the data. And then the labeled data are given to the machine learning model, which trains a classifier to output an accuracy. And this is our active learner system. We start from our model, which is the architecture we saw before, and we add to it several dropout layers to create artificially several different models. And all these different models will create the committee of models, which will lead us to make predictions. So we give an input sentence to this committee of models, and each model gives a prediction about this input sentence. Is it a risk sentence or not? And given this pool of prediction, we can compute an uncertainty score. So how much these different models agree together or not. And if this uncertainty score is really low, it means it's super hard to classify this sentence. So we will give it to the annotator to annotate and to give it then to the machine learning model. So we did 6 iterations of this system, and so we labeled in total 2,200 sentences. And we can see on the graph on the right that each iteration increases the accuracy of the classification. So in the end, we obtain an accuracy of around 0.89 points. And we extract around 200 risk sentences for each report. So around 3.6% of the full annual report. Now that we have a list of risk sentences, we can actually map all the risk factors together. So because we want to do this because we need to define a list of risk factors to be able to say if one is missing or not. But there's no normalization. The regulators, the AMF doesn't give any list to the companies to check, yes, we see this one, or yes, we don't see this one. So to create a list of risk factors, we need to use unsupervised methods. And the next step will be to map these risk factors depending on the characteristics of each document. So we'll know which risk factors are specific to a sector, business line, or which year of reporting. And this will allow us to deduce the risks that are more specific to each sector or each period. So to do unsupervised classification, we have 2 possibilities. We can do it at the sentence level using clustering. So in that case, we will use k-means, and at the document level by using topic modeling methods. So we use LDA. To begin with, sentence clustering. So we use our sentence presentation that we got during the first step in our encoder. So the sentence presentation outputted by the Flowbird model. And we use k-means algorithm. In this case, k has to be chosen, manually set. So we decide to use the financial literature to decide what should be k. So what should be the number of risk factors that exist in all financial reports. And usually in the literature, financial experts state there's around between 20 and 25 different risk factors. But however, we think that sentences that are close in a document have high probability to deal with the same risk factor. It's intuitive because usually they come in a paragraph and they are close, so they deal with the same subjects. So we tried to improve the clustering by adding additional features as a representation of a surrounding sentence to make a better accuracy and a better clustered system. So we augment the k-means algorithm with a window of surrounding sentence, using as feature the representation of a surrounding sentence weighted by the distance to the target sentence. And we use as a metric the silhouette score to know if the clustering is good or not. And we see that using a window of 4 sentences, the silhouette score is the higher, while with a window of 2 sentences is a bit lower, and with only the basic k-means without augmenting it, we have a score even lower. The other method we apply is topic modeling. So we use the most popular one, LDA, that is quite old but super well performing. The main idea is that each document is characterized by the distribution over a set of topics, and then each topic is characterized by a distribution over all the words of the vocabulary. So it will allow us to know what are the more specific words for each topic, so to make an interpretation of the topics. We have to choose for LDA the number of topics, and we choose it as the same as the number of clusters, so between 20 and 25. And here, for example, you have some results of LDA applied to our data. So some keywords associated with some topics. For example, on the first one, you have agency, advertiser, publicity. So it seems that it's related with the reputation risk. Another example is property, intellectual, license, brand, software. So all these keywords that seem to be related with the patent and other risk related to it. And finally, another topic is specific, characterized by the words oil, exploration, hydrocarbon, and damage. So all risk related to energy. So this can allow us to make intrinsic evaluation. However, we have these keywords only for topic model, not for k-means. So how could we do to have the same information to make a joint evaluation to compare k-means and LDA? So for this, we will extract actually keywords from each cluster outputted by k-means. And to do this, we use simply the TF-IDF score. TF-IDF means term frequency, inverse document frequency, and it's a simple measure that we can apply to our clustering. We take each cluster as one document, so the set of clusters is a corpus, and it allows us to get a TF-IDF score for each word inside each cluster. So simply, we can take the words with the highest TF-IDF score in each cluster as the word that characterize the cluster best. So we end up with a set of cluster or a set of topics, each characterized by a set of keywords. And we can use several quality measures from the topic model literature to evaluate how these topics or clusters are coherent and diverse enough. So we have 3 measures that you can see on the slides, 2 coherence measures, NPMI and word-to-vec coherence, and a topic uniqueness measure. And on the table on the right, you can see the results. So LDA is has slightly more unique clusters than k-means. So it means there's more diversity. The clusters are more separated from each other. And in terms of coherence, it's a bit different. LDA seems more coherent from a point of view of NPMI, which relies on word co-recurrences, while k-means seems more coherent from point of view of word-to-vec, which relies on pairwise similarity using pre-trained word weddings. So as we're not sure which one is better, we will use both methods for the last step, which is the deduction of omissions. So to finish the step 2, we have from our methods topic modeling of or clustering a distribution of risks for each document, as you can see on the left image on the slide. From this, we binarize the results. So if a document includes a topic or a cluster with a proportion which is too small compared to the other topics or clusters, we consider that it's the risk is not reported by the document. So we end up with a list of risk reported for each document. And each document is linked with its metadata, so the sector and the period. So the last step, the third image, allows us to select which risks are the most specific for each sector or each period. So these typical topics will help us to know if this typical risk will help us to know if one risk is missing from an annual report or not. So this is step 3, detecting omissions in annual reports. So we have 2 goals. First, to detect if a risk factor is missing, and then to identify which is the missing risk factor. So we don't have actually any ground truth, any labels on missing elements in a document in an annual report. So we will do it manually. We take a random document and we remove one risk subsection. So we have now an adult document with some risk missing, and we pass it through the LDA or the k-means that we treated previously, and it outputs a list of risk factors. And we can compare it with a list of typical risk factors of the same year. Here, for example, is 2008, and the same industry of the document, the same sector. Here, for example, industry. So from these lists of typical factors and the actual list that we found in the document, we can deduce a list of missing risk factors. And the next step is the evaluation. From the removed risk subsection, we apply the fitted LTI k-means to detect which factors that was removed, and we compare it to the list of missing risk factors that we got from the typical risk factors of the same year and industry. And if there's same risk in these 2 elements, we consider that we successfully detected the omission in the risk in the document. So these are the results. for LDA, k-means, and k-means augmented with 2 sentences in a window of 2 sentences or a window of 4 sentences. And the accuracy is made by using only the sector information, only the year information, or both. What we can deduce is that the sector is more discriminant than the year. So the typical risks for a sector are more discriminant, while the typical risks for a year are much harder to detect. And the other conclusion we can make is that the clustering method is much more efficient than the LDA. But we can assume this is due to the representation, because the k-means method is based on the sentence representation that we got from the first step, so the sentence encoder related to the model BERT, which leads to really high quality presentation of sentences, while the LDA is only based on word concurrences. So of course, the representation has much less information, so the quality is much lower. We can maybe improve this by using more advanced topic modeling method based on word embeddings or pre-trained language models to see if it reaches the same accuracy as a k-means method. So to summarize, this work was about introducing a new task of detection of omission of risk factors in annual reports. And so we proposed a pipeline to tackle this problem, which first extract risk sentences from annual reports using an architecture with an encoder and a classifier on top of it. Then we extracted the risk distribution of each annual report using unsupervised methods, topic models, or clustering. And finally, we generated synthetic risk factors omission in a sample of annual reports and detected them and proposed a metric to give an accuracy for all the methods. So this paper was published during the year at a financial NLP workshop, which is collocated with the ISHKAIG conference. You can find it online under the title Detecting Omission of Risk Factors in Company Annual Reports. And thank you for listening. And if you have any question, you can post it in the question tab. Oh, the strategy to choose the unlabeled data. Okay, so this is about active learning. So to choose the unlabeled data, on the first step, it was just random. We really just we tried to take it, to sample it evenly on the whole data set, but we started with only 400 data to label, 400 sentences, and then we used the active learning method to much better select the unlabeled data to label. Is there any other question? Okay, we have only 2 minutes left before the end of the meetup anyway. So, okay, I will conclude this meetup then. Thank you everyone for attending. And if we can summarize everything that was said, then just keep learning all the time and keep sharing all your knowledge and keep attending meetups. Thank you, everyone.
Thank you, Ceriel. Caroline has to leave us earlier. She would love to conclude this meetup also. Thank you, Ceriel. It was very interesting to share your work. This meetup comes now to an end, as you announced. In the name of all the speakers today, thank you all for your attention. It was really great to interact, and it was really a great pleasure to share with you and see your interest and questions. Before maybe to say goodbye, I would just, in the name of Société Générale, would like to cheerily thank the Paris Women in Machine Learning and Data Science Organization team for this joint event. It was a beautiful project. I would like to thank Caroline, Nathalie, and Marie, and also thank our partner Startup Inside, the organizer of AI for Finance, for their invaluable support, especially Emma and Fanny. Thank you. Bye-bye.